right, your homework tonight is to watch this video and take notes on the handout that you were given, and it is all about finding the meaning of slope. So here's our first example that we're going to go through together. Part-time job. You got a job at a newspaper factory and have been tracking the money you've been making. Find the rate of change. So we're going to use this graph. To find the rate of change or the slope from a graph, first we need to find 2 points on it. And we could pick any 2 points, but I always look for points that are really easy to identify. So right here is a nice point, and I'm going to label it. It's the point 550. And another nice point is right here, which is the point 10, 150. So remember, slope is rise over run. So let's find the rise first. So the rise is going from, it's at 50 at the first point, and it's at 150 at the second point. So the difference in those two values is 100. So our rise is 100. And our run is going from 5 over to 10, which is a change of 5. So the rise over run is 100 over 5, which we always reduce, and so that reduces, it really means 100 divided by 5, which is 20. So our slope, or our rate of change, is 20. Okay, we did the first part. Then explain the meaning of the slope in this situation. The best way I know of to do that is to first give the slope, but give it as a fraction. So 20 as a fraction is 20 over 1. And now once you have it as a fraction, put the units on it. So the 20 was the rise, which in this case was the money earned. So it's dollars is the unit. So $20. The 1 is the x variable, which is weeks. So 1 week. And we just have to turn this into a sentence. And I usually start with the bottom, the run, or the x variable, and say each 1 week, or each week, this is talking about money earned, so the money earned goes up by $20. You could say it slightly differently, but I think this is probably the easiest way to say it. So let's look at another example. This time we have a table, newspaper factory. So the newspaper factory, well, makes newspaper. It produces newspaper at a constant rate. A partial table of data is shown below. So we only have 3 complete ordered pairs here to find the rate of change from. We could pick any 2 of them and it would work. It should be the same. I'm going to choose the first 2. So 3, 270 and 6, 450. And I want to find the change in y and the change in x, which is same as rise over run, but just another way to say it. Change in y over change in x. So to find the change in y, so remember, the x is always the one on top, the y is the one on bottom in a table set up like this. So change in y, I need to figure out what is it changing from 270 to 450. And if you can't do that mentally, you could write it out. What we're really doing is we would be subtracting 450 minus 270. And so that seems like it would be about 180. So it's going up 180 from 270 to 450. And then the change in x is going from 3 to 6, it's going up 3. So then we reduce. 180 divided by 3 is 60. Okay, so 60, and then to give the meaning of that, I'm going to write it as a fraction, which is 60 over 1, and I'm going to put my units on it. So the 60 was the y value, because it was the rise. So that's newspapers, number of newspapers. So 60 newspapers, and then the 1 was the x, which was hours. So 60 newspapers for each 1 hour. So to give the meaning, we could say every hour, or each hour, 60 newspapers are produced. We could also have said every hour there are 60 more newspapers. That would be another way of saying basically the same thing. Okay, so one more example. Rain, rain, go away. Rain is falling at a constant rate. After 2 hours, there are 2 centimeters of rain. After 6 hours, there are 8 centimeters. So there's several ways to do this. I would probably set up a table to see these. These are really showing two different ordered pairs. So if I made a table, and if I had X and Y, I need to figure out which variable goes where. So I have hours and centimeters of rain. I think that the centimeters of rain is going to depend on the hours, which means my hours is going to be the independent. So this is like the time in hours. And then the y is going to be the centimeters of rain. Okay, so I know at 2 hours there are 2 centimeters of rain, and at 6 hours there are 8 centimeters of rain. So kind of like the example before, we can find the change in y and the change in x. So the change in y, it's a little easier here. From 2 to 8, that's going up 6. And from 2 to 6, the change in x is going to be up 4. So my rise over my run, or my change in y over my change in x, is 6 over 4. And this reduces to 3 over 2. And we can just keep that as a fraction. We don't, it's also 1.5, but we don't need to say that. We can say 3 over 2 as our final answer for the rate of change. Now to give the meaning of the slope, I keep it as the fraction 3 over 2, and then the 3 was the y, which was centimeters of rain, and the 2 was the x, which was hours. So we can say every 2 hours, there are 3 more centimeters of rain. If you don't like fractions and you wanted to use 1.5 over 1, which you can do, you would just say each hour there's 1.5 centimeters more of rain. All right, those are our 3 examples, and then the last thing you have to do to get credit for this being your homework tonight is to write a summary. So I know you don't have a lot of room on that paper, so if you can squeeze it on there, or you can go to the back of that notebook page, I want you to write a summary of how to give the meaning of slope. All right.